Lesson 7.5, Properties of Trapezoids and Kites. A trapezoid is a quadrilateral, so four sides, with exactly one pair of parallel sides. Only the one set are parallel, the other two sides are not. The parallel sides we call bases. The non-parallel sides we call legs. If the legs happen to be congruent, then we say the trapezoid is isosceles. Still one pair of sides parallel, the other two sides are not. If a trapezoid is isosceles, then each pair of base angles are congruent. So the two at the top and the two at the bottom would be congruent. And also, if it's an isosceles trapezoid, then the diagonals are congruent. Converses are also true. Here's a graph we're supposed to show it's a trapezoid. If it's a trapezoid, exactly one pair of sides are parallel. Well, if they're parallel, these would be the two sides. And to find out if they're parallel, we'd have to use slopes. So remember the slope formula. y2 minus y1 for x2 minus x1. So the slope of the BC at the top, y2 would be 2, y1 would be 3, x1, y1, x2, y2. x2 is 3, x1 is 0. So that gives me negative 1 over 3. For AD on the bottom, again I can call this x1, y1, the other one x2, y2. y2 is negative 3, y1 is negative 1. x2 is 4, x1 is negative 2. Minus a negative is a plus, so this is negative 2 over 6, which is negative 1/3. Those are the same, therefore we know BC is parallel to AD. So, ABCD is a trapezoid because one pair of sides is parallel. It's obvious from the picture the other pair of sides would not be, since one is sloping up, the other sloping down. Now, is it isosceles? To be isosceles, the legs would have to be the same length. So we'd use our distance formula. Alright, so now for AB, maybe I'll call A x1, y1, and B I'll call x2, y2. So x2 is 0, x1 is negative 2. y2 is 3, y1 is negative 1. Alright, so this is 2 squared is 4, and this is 4 squared is 16, so that's the square root of 20. Let's simplify that. 20 is 4 times 5, square root of 4 is 2, so it's 2 times the square root of 5. Let's find the other legs, CD. C, I'll call x1, y1, D can be the 2's. So x2 is 4, x1 is 3, y2 is negative 3, y1 is 2. So this is 1 squared and negative 5 squared, so that's the square root of 26, which is only 2 times 13, so we can't simplify. So we look at those. Are those the same? No. AB is not congruent to CD, so ABCD is not isosceles because the legs are different lengths. All right, let's say this trapezoid is isosceles, which means the legs are congruent. And measure of angle EHEF, so this whole angle is 70. Find the measure of EFG, so this whole thing here. And FGH, this one there. And GHE, that one there. All right, so I want the whole angles everywhere. Well, in an isosceles trapezoid, the base angles are congruent. So that means the angle at F is going to be the same as the angle at E. So the measure of angle EFG is also going to be 70. All right, let's find the others. Those are parallel lines. So that means angle HEF and angle GHE are consecutive interior angles. According to the consecutive interior angles theorem, if we have parallel lines, the consecutive interior angles are supplementary. So they add up to make 180. So 70 plus measure of angle GHE have to equal 180. Therefore, measure of angle GHE is 110. And again, the base angles are congruent. So that means the measure of angle FGH is also 110. Trapezoids also have another important piece called a mid-segment. We had mid-segments for triangles. So this is the mid-segment for a trapezoid. It connects the midpoints of the legs. So it connects the midpoints of each leg. The mid-segment theorem says the mid-segment of a trapezoid is parallel to the bases. Mid-segment is parallel to the bases. And its length is the average of the lengths of the bases. That's 1/2 B1 plus B2. That's similar to the mid-segment of a triangle, which we said was parallel to the other side and half the length. Same idea, it's parallel and half the average, halfway in between the other two. Trapezoid JKLM, J and M are right angles. Okay, so I need two right angles. So we have J and M. See how this works. This could be JKLM. It says JK is 9. The length of the mid-segment NP is 12. And if that's the mid-segment, then it's in the midpoint. Find ML. Well, we know from the mid-segment theorem that the mid-segment is 1/2 of B1 plus B2. It's the average of the two bases. Here our mid-segment is 12, and my bases are 9 and X. So to solve for x, I'll multiply by 2 to get rid of the half. Subtract the 9. And x is 15. Notice, from 9 to 12 is 3. From 12 to 15 is 3. So the 12 is directly in between, lengthwise, between the 9 and the 15. Kites. What are kites? Kite is a quadrilateral of two pair of consecutive congruent sides. Now, since opposite sides are not congruent, it's the consecutive sides that are congruent. Kites are not a parallelogram. By the way, neither are trapezoids because the legs are not parallel. Anyway, two pairs of consecutive congruent sides. If you have a kite, the diagonals are perpendicular. And if we wanted to, we could prove that. Draw that one. The top and bottom triangles are congruent by SSS, which means this angle is congruent to that angle. And then we can draw this one. And then these two triangles are congruent by side angle side, which means this angle and this angle are congruent. And so if they're congruent and a linear pair, they're 90 degrees. So perpendicular. Also, in a kite, one pair of opposite angles are exactly congruent. And they're the angles that are between the non-congruent sides. The other pair of angles are not congruent in a kite. Alright, so we're supposed to find measure of angle C. Now, since it's a kite, because I have these two sets of consecutive congruent sides, we know that one pair of opposite angles are congruent. So C is congruent to A, so I could call them both X. But how does that help? Well, it's a quadrilateral. If I add up all the angles in a quadrilateral, they have to equal 360. X plus x is 2x. 80 plus 50 is 130. Subtract the 130. Get 2x equals 230. Divide by 2, and x is 115 degrees. So measure of angle C and the measure of angle A are 115 degrees. Let's have a chart to summarize everything we know about quadrilaterals. We have generic quadrilaterals. What are quadrilaterals? They have four sides, and the sum of interior angles is 360. Some quadrilaterals are parallelograms. What do you know about parallelograms? Well, the definition, opposite sides are parallel. We also know that the opposite sides are congruent. We know the opposite angles are congruent. We know the consecutive angles are supplementary. And we know the diagonals bisect each other. But since parallelograms is a smaller set of quadrilaterals, it also has all the properties of quadrilaterals. The interior angles have to add up to 360, and they have to have four sides. Some parallelograms are rectangles. All rectangles are parallelograms, but there are other parallelograms that are not rectangles. What special properties do we know about rectangles? Well, we know there are 4 right angles, and we know the diagonals are congruent. But they also have the properties of the parallelograms and the quadrilaterals. Opposite sides parallel, opposite sides congruent, diagonals bisect each other, and so on. Some other parallelograms are rhombuses. It's a rhombus, 4 congruent sides. And what else do we know? We know the diagonals are perpendicular, and we know the diagonals bisect opposite angles. Plus all the properties of parallelograms and quadrilaterals. So from the quadrilaterals, some are parallelograms, some parallelograms are rectangles, some parallelograms are rhombuses. If it's both a rectangle and a rhombus, then it is a square, which is 4 right angles and 4 congruent sides, and all the properties of everything up above it. Diagonals are perpendicular, diagonals bisect opposite angles, diagonals are congruent, they bisect each other, opposite sides are equal, opposite sides are parallel, and so on. So that's the parallelogram family. We have other quadrilaterals, trapezoids, which is 1 pair of parallel sides in a trapezoid. And we had special trapezoids that were isosceles. If it's isosceles, the legs are congruent, the diagonals are congruent, and the base angles are congruent. Those are trapezoids. And then lastly, we had kites. What were kites? Kites were 2 pair of consecutive congruent sides. We had some other properties though. We knew that the diagonals are perpendicular, and it has 1 pair of opposite angles congruent. So that's almost everything we've learned in this chapter. The only other thing we learned were the sum theorems for polygons. Polygons are actually up above quadrilaterals. In polygons, the sum of the interior angles was n minus 2 times 180 degrees, and the sum of the exterior angles were 360 degrees. And this was if it was convex. That's everything we've learned. Let's do a few more examples. Give the most specific name for the quadrilateral. Now this is congruent to that. This one's congruent to that one. Notice all 4 sides are not congruent. We have 2 pair of sides that are congruent to each other. And they're not opposite. They're consecutive. So that makes it a kite. About this one. Well, we have 1 pair of parallel sides. So it's looking like a trapezoid, but now is an isosceles trapezoid. If it was isosceles, the diagonals would have to be congruent. So let's see if the diagonals add up to make the same thing. This one is 144. The other one is 137. Those are not the same. So this one is just a trapezoid, not isosceles, it's just a trapezoid. And then this one. I have one pair of opposite sides congruent. I get one diagonal that's bisected, and I don't know anything else. I don't have enough to show it's a parallelogram, so I only have one pair of opposite sides congruent. I know nothing about parallel. I don't know that the diagonals bisect each other. I know nothing about the angles. So let's eliminate parallelograms. It's not a trapezoid because I don't know any parallel sides. And it's not a kite because the consecutive sides would be congruent for a kite. This is the one pair of opposite sides. So I can't show it's anything other than a quadrilateral.